Hello everyone. So today I will discuss one of the most frequently asked question in an interview. So I faced 5 out of 10 interviews. I faced this question, and the question is like how internally HashMap works, like during put and get, how it basically works, right? So let me share that. So let's say I want to add these three values. So there might be multiple values that we want to add. Let's say at first we want to add these three values. So how HashMap is basically initialized. Let's say this is initialization, right? So here you can see the load factor. This dot load factor is equal to default load factor. So this is the value load factor. So I'll talk about what is load factor after some time. But before that, we need to know, like, whenever there is any HashMap is initialized, its default capacity is around 16. Okay, so let me tell you about it, like how it is stored internally. So we know that we have a map entry interface, right? So in HashMap we have one class called node, static class. This is node, and it has 4 values like hash, key, value, and next. Okay, and it implements map entry. Okay, so how it looks like is like this. Let's say I have one node. It's like this. Okay, so so it's like a node array. Okay, so this is an array of node. Okay, so here if you see, so basically array that has been declared here. Okay, now so this is the array that I was talking about. So this is basically the node array. It has, each element has key, value, and next. So if you go inside this, it has key, value, and next. Okay, so has key, value, and next. So first what we basically do is okay, so here let's say what we want to save. Let's say we want to save 123, right? So there is a key and value pair. Okay, so let's say key equal to 1 and value is 23, right? So how we basically store the value in HashMap is, first we calculate the hash value of key. Okay, so we calculate, let's say, hash value of key. So it's, let's say its hash value is 2 3 4 5 6, something like this. Okay, and then we mod it using the total length of the array. So in this case we have total 4 elements here. So we mod it using let's say this number has value with 4. Okay, now the value, let's say it comes as 2. Okay, now what we will do is basically we'll put the element over here. Okay, so let's say this is 1, and then we have 23. Okay, and next is null. Here there is no next, so it is null, and this value is 2 3 4 5 6. Okay, now let's say I want to add another element. Let's say k equal to 2. Okay, and value is, let's say 25. Okay, now I'll calculate the hash value of this. Let's say its hash value is 1 2 2 3 5, something like this, and then mod 4. Let's say it comes as 0. Okay, now its value will be, like, hash value will be here. It will check if hash value is present in this block or not. Okay, so it will check. It will basically check that the 0th index, its value is 0, so it will put it over here because there is no element in this bucket. So now key will be 2 and it will be 25. Okay, and this will be null. Okay, so now this all bucket is not present. I've just put it. I'll discuss this one by one. So let's say now next is null. Okay, there is no element like this. Okay, now let's say I want to add key equal to 3, key equal to 4, like that. And let's say all of them are coming as like all of these has value. So how to calculate has value? There are many other many ways to calculate has value, like MD5 and something like that. But sh1 some has function we have, so we can use those, or we can create our own has function. So using that we can calculate the has value, and then we basically mod it with the number of element we have, like, or the size of the array, and then we'll get one index, and that in that index we'll basically put all this different values. Okay, let's say now all of these keys are mapped to 0 index. Okay, now I will check like if has value is same as before or not. So like in HashMap we have two method, basically hash code and hash code, which basically generate the hash value, and we have equals. Okay, so one thing is always true is that if both objects are same, their hash value will always be same. But if both objects are if hash value is same, it is possible that object might not be same. Okay, object might not be same. Okay, so what we basically check when we check if both the element are same or not, right? So what we basically check is, first we check if hash value is same. Okay, if hash value is same, we check if keys are also same. If both keys are also same, then what we'll do, let's say we want to add 2 and key is 2 and value is 29, right? So in this case both key, like this 2 and this 2, both are same, right? So now we will replace this 25 with 29, right? Okay, so we'll not create another element, we'll just replace this. How? Because in equals method we get to know that both the has value is same, both key equal to 2, its value is has value is same, but its and its key is also same. So in this case we get to know like these two objects are equal. Okay, so now we will add this value 29 here, right? Okay, now let's say I want to add 3 and 4, and all of these has values are also mapped to 0th index. So now what we'll do, I will add like has, okay, it's has value, let's say something, and then key equal to, let's say 3, and value is something. Okay, and then next. Okay, now this next will be updated with this address. Okay, so this address it will update. Okay, same way like here also key will be 4. Okay, here also let's say key or 5 are also here, right? So this way it basically gets stored. So here we have basically two concept or two parameter that is basically load factor. Okay, so one is load factor. So what is load factor? If you see here, default load factor is 0.75 load factor. Okay, so if you see the load factor, default load factor, so default load factor is 0.75. So what is this mean? Like let's say the total HashMap size is 16. Okay, so as I have showed you earlier, like the default initial capacity is 16. Okay, so default initial capacity is 16. Okay, and load factor is 0.75. Okay, now what it will do is basically when we map at least 12 elements. Okay, so 16 into 0.75 is 12. When we map at least 12 element to a newly created hash map, and after that if we want to add another element, in that case what it will do, it is basically resize its size becomes 32. And again, if let's say it's become 24, okay, load factor is 0.75. So once we reach 24 element, and then next we want to go to add another element, that is 25th element, in that case it becomes 64. So every time it get multiplied by 2. Okay, so like that the size of the hash map get increased. Okay, now let's say it is possible that in like our size of this array is 16, but still our hash map is like hash function is such that all the elements are basically mapping it to 0th element, right? Now what in that case our linked list size will increase a lot, right? So, but we know that from hash map, the average time complexity is order of 1. Like searching complexity is order of 1, right? Now, how we handle that? So basically, here there is another concept, like if you see here, tree phi threshold. Okay, so this is 8. So what happen is, let's say if this linked list size becomes more than 8, in that case it will tree phi. I mean, it will become a tree, like a binary search tree, balanced binary search tree. Okay, so it becomes a balanced binary search tree. Okay, so what is the example of balanced binary search tree? It is basically a red black tree. Okay, so red black tree. Okay, now so how it looks, so balanced binary search trees basically look like this. Okay, so it's like 5, then 4, then 2, then it is let's say this is 6, and then it is 5. Okay, now this is 8, 7, 9, like that. Okay, so in this case searching is basically order of log n. So in the worst case time complexity of searching is order of log n, but at first we should mention that it's order of n in case it's when it is like linked list, it looks like order of n, but it never be an order of n, because after this 8, when the linked list size become 8, it will basically convert this linked list to tree, balanced binary search tree. So the worst complexity of searching is order of log n. Okay, so this is how we basically store element into hash map, and we like let's say we want to search or we want to fetch value for 4, right? So in that case we'll first generate the hash value. Okay, so in this case hash value will generate, and then we'll divide it by the number of size of the hash map, and then we'll go into that index, and then we'll search one by one. First we'll check if the hash value is same. If the hash value is same, we need to check if the keys are also same. So here equals method comes into picture. Okay, now if both are same, at that point we get to know like this is the element that we are searching for. Okay, so now here from this linked list we'll get this 4. So this is how the searching happens. Okay, so in case, so yeah, once it reaches to the let's say this is the size of this array is 16 and it reaches to 12. So at that time it will increased its it will basically resize it. So hash map get resized to 32. Okay, and in that case again it will recalculate the hash, and it will like recalculate the hash and store the value accordingly. So if you want to see that how it basically resize it, so this is the function. So this is the function, you can check. So resizing happen, okay, once it reaches to the like a load factor, okay. So yeah, that is what I wanted to discuss. If you got some valuable information from this video, please like, share and subscribe to my channel. Thank you so much.